This question will be on your test, okay? So make sure you study. Okay, so now let's look at this. What is this? Write the converse of the following statement. If the converse is true, write true. If it is not true, then provide a counterexample. So, if x is less than 0, then 9x is less than 0. So, the first thing you should do, guys, on your paper, please do the converse on your own. Do not try to look at it through these answers. You will get confused. So, let's write the converse of this. If 9x is less than 0, x is less than 0. Okay, so let's start looking. This is the converse right here. So let's start looking at what things we can take off. Okay, this is wrong because they completely switched the sign. Switch the sign. Switch the sign. And switch the sign again. There's no greater than or equal to or less than or equal to here, so I don't know why they're doing. They're just trying to trick us. Okay. So we got that it could either be A or E. So now let's look at the reason. Is this true? Okay. To figure out this is true, let's actually solve for this. So over here, we're going to solve for this. So 9x is less than 0. What is 9 divided by 9? That takes it out. So x is less than, what's 0 divided by 9? That's 0. So that means this is true, right? Because what does it say here? This should be what's on this conclusion, and it is. So this is true. Because when I did this, what did I get when I solved for x? I got x is less than 0. So this is true. Okay. Okay, now we're on 2.4. So 2.4.1. So the first question of 2.4. Now we're talking about biconditional statements, right? And remember, with our original statements, with the 4 original ones, we have the conditional, converse, inverse, and contrapositive. With biconditional, we need to have it with the phrase if, and only if. With the original statements, we needed to have it in the if something, then something. With biconditional, we have if and only if, and we take away this if and then. You do not need these anymore when you're making a biconditional statement. So let's read the question. 2 angles are supplementary if and only if the sum of their measures is 180. So let's look at the instruction because I completely missed the instruction. Write the 2 conditional statements that form the following biconditional statements. So we know that when we have a biconditional statement, what do we know that this can be broken up into? This could be broken up into a conditional and a converse. So what they want us to write is pretty much our 2 answers here are the conditional statement and the converse statement. So let's find them. So what is the conditional of this? Let's try to do it here first. So if 2 angles are supplementary, we ignore this, right? Because now, whoops. So if 2 angles are supplementary, ignore this because if and only if is for biconditional, right? What are we looking for? We're looking for the conditional. So if 2 angles are supplementary, then the sum of their measures is 180. So where does that say right here? Look, this one, C. So that's my first answer. Now what's the converse? If the sum of their measures is 180, take this out, then the 2 angles are supplementary. So if the sum of their measures is 180, then the 2 angles are supplementary. So these are our 2 answers. Okay? Write the 2 conditional statements that form. Okay, so same thing. So when you're writing the 2 statements, you write the conditional and the converse. So let's find the conditional and converse of this biconditional statement. So once again, we're going to take this if and only if out. Okay, so our conditional is if x squared equals 144, then x equals 12 or x equals negative 12. So where's that? Right here, C. And the converse would just be the switching of this, right? So it would be if x equals 12 or x equals negative 12, then x squared equals 144. That is B. So our two answers are B and C. Please make sure you're reading the instructions. It says, what are the two? Two. So that means you need two answers, so please don't just click one. Read your question. Okay. Consider the true conditional statement. If two angles are complementary, then the sum of their measures is 90 degrees. So they first want us to write the converse. Well, we know the converse is just the switching of the hypothesis and the conclusion. So our converse should be, if the sum of their measures is 90 degrees, then the two angles are complementary. So if the sum of the measures is 90 degrees, then they're complementary, okay? If the converse is true, combine the statements as a biconditional. If the converse is false, what is the counterexample? So let's take a look at this conditional. If two angles are complementary, then the sum of their angles is 90. That's true. Yeah, that is true. Now let's look at the converse again. What was it? If the sum of their measures is 90 degrees, then the two angles are complementary. That's also true. So if we just figured out that the conditional is true and the converse is also true, then what can we do? We can make a biconditional statement. So my biconditional statement should be if no, you see I made a mistake. I put if. With biconditional, you take out the if. You take out the if, and you take out the then. And right here, what do you put in the middle? If and only if. So, two angles are complementary if and only if the sum of their measures is 90 degrees. So where's that? Right here. Letter A. So if the converse is false, which of the following? It was not false, so we just put the converse is true. We do not find a counterexample when it was true, okay? You only need to find a counterexample if something is false, okay? So what about here? Okay. Consider the statement, a right angle C measures 90 degrees. Okay. Write the statement as a conditional statement. So conditional statement needs to have what? If and then. So let's look at the first one. Write the given statement as a conditional, choose the correct answer. So this as a conditional is what? If a right angle, if C is a right angle, then measure of angle C measures 90. So let's find something like that. So I know A is wrong automatically. Let's look at A. Why is A wrong? Because we started with what? The conclusion. This is the Q, and this is the P. Let me put down the top. This is the Q, this is the P. So I know this is automatically wrong. Okay, not. Why do you have the word not? That's not what I want, okay? Oh, look, another not right here. A is not equal, so this is also wrong. Do converses, do conditionals have a negation of something? No, we do not need to negate these, okay? So our answer is D. Let's look at B. If the conditional statement is true, which of the following is the converse of the conditional? So let's figure out if this is even true. If angle C is a right angle, then measure of angle C measures 90. Yeah, that is true. So now let's find the converse of that. Let's switch it. If measure of angle C is 90 degrees, then angle C is a right angle. That is B. So now, if the conditional statement is false, which of the following which of the following is a counterexample for the conditional? So let's see if this is false. If measure of angle C is 90, then angle C is a right angle. That's true. So we just write the conditional as true. There's no need for a counterexample, right? The last part of this question is over here. It didn't have enough space. So if the converse statement is true, write a true biconditional statement. So it was true. So let's look back at our original statement. Okay. Remember that this as a conditional. Okay. Oh yeah, we don't even need that, right? Because what do we know? When it's biconditional, do we have an if and then? No. When it's biconditional, we only need to put if and only if. So our biconditional should read something like, notice how I'm not looking at the answers yet. I'm just looking up here. I'm not looking over here. I don't care about this yet. This is going to trick me. I want to figure out my own biconditional statement and then match it with one of these. So a right angle C, an angle C is a right angle if and only if it measures 90 degrees. So it should be something to that effect. So let's keep reading. Angle C is a right angle if and only if it measures 90 degrees. Yep, this is the answer. And we clearly see here that they negated it and we did not want a negation. Okay? If the converse statement is false, which of the following is a counterexample? It wasn't false, it was true. So we don't even have to worry about this because we know that the converse statement was true. Okay? Is the following statement a good definition? If so, rewrite it as a biconditional. If not, explain. Okay, so remember, for something to be considered a good definition, it has to be one, it has to be measurable. There can't be any opinions or like, oh, it depends. No. It needs to just be straight facts. And the other way to tell something is a good definition is if it can be turned biconditional. Okay, so let's look at this sentence. Okay. Collinear points are points that lie on the same plane. So let's make a conditional statement of that. So if I want to make a conditional statement of this original sentence, let's make it. Collinear points are the points that lie on the same plane. So if points are collinear, then they lie on same plane. Okay? And we need a conditional and we need a converse. So what would be the converse? Well, it's actually pretty easy because we already got our conditional. Right? We're just going to flip this and this. So if points lie on same plane, then points are collinear. Okay, so we just made a conditional and a converse. So let's see if this is true and this is true. Because if they're both true, then we know we have a true biconditional statement. So if points are collinear, then they lie on the same. Oh, I put plane. My bad, guys. Have I been saying plane this whole time? Oops. Line. Line. Same line. Line, Jesus. Okay. Line. Okay? So, my bad. So, if points are collinear, then they lie on the same line. That's true. So, that's good. True. If points lie on the same line, then they are collinear. That's also true. This is straight up just the definition of what collinear means, right? So, we know that they're both true. So, if they're both true, we can indeed make a biconditional statement. So, let's do it. Collinear points are collinear if and only if they lie on the same line. It should be something like that. So let's look for that here. We can already take out the no's, right? So it's just about looking at A and D. So let's look at D. Yes, because if the points are collinear, then they lie on the same line. Okay, the first thing I noticed that was wrong was it had if and then. That's not a biconditional statement. It needs to have what? If and only if. So this is your correct answer, A. Okay. Which of the following conditional statements and its converse form a true biconditional? So let's take a look at this. If x is less than 0, then the absolute value of x is greater than 0. Okay, so what I like to do, these are really hard, so what I like to do is I like to give examples for these. So for example, if x is less than 0, I'm going to start thinking of some numbers that are less than 0. Let me put this really small. So what numbers are less than 0? I have -1, -2, -3. Okay, then absolute value of x is greater than 0. Okay. Okay, that's true, because if I put -1 onto here, and -2 onto here, and -3 onto here, that's going to work. Yeah, okay, so going this way, this is actually correct, because if x is less than 0, what are some numbers that x is less than 0? -1, -2, -3. Let's put those same x's onto here, because this x and this x are the same, right? Because they're in the same statement. So now, is -1 absolute value greater than 0? Yes, it is. Is -2 absolute value greater than 0? Yes, it is, because an absolute value turns anything, what? Positive. So any positive number is greater than 0, so that's obvious. But what if we flipped it around? So if if absolute value of x is greater than 0, what are some numbers that could be in this absolute value that would make it greater than 0? Well, I could have 1, -1, -2, and 3, but can't I also have 1, 2, and 3 as well, the positive ones? Yeah, I could, right? Because -1 absolute value is 1, 1's greater than 0, that's good. -1 absolute value is 1, okay, so that's good. So if x is great, if absolute value of x is greater than 0, then x has to be less than 0. Wait a minute, didn't we just say that 1, 2, and 3 are possible answers for this? Yeah. So if this, correct? I don't want to keep repeating it. If this, so what can x be? 1, 2, and 3. Then x must be less than 0. Wait a minute. Is 1 less than 0? No. So this is only true in this conditional form, but its converse is false. So this cannot be a conditional statement. So I'm already going to go, where's this one? This one is wrong. Let's look at the second one. If x is -2, then x squared equals 4. Yes, that's true, because -2 squared is what? 4. But if we flip it around, if x squared equals 4, then x equals 2? No. X squared equals 4. Remember, when they straight up just give us this, the answer is 2. But if they give us something to solve for, your x is equal to positive and -2. And because it's positive and -2, that means that this is not fully correct. So this one cannot be a biconditional. So let's erase that. So get this next one. If x to the 3 is 2, then x equals 8? No. Guys, 8 to the 3 is like 8 times 8 times 8. What's 8 times 8? That's 64 times 8. I mean, I don't want to do this math, but it's way bigger than 2. So this is just straight up wrong on itself. That one was kind of obvious. So now let's look at this next one. If x is equal to 19, then 3x minus 4 equals 53. So what's 3 times 19? 19 times 3, 27, 57, minus 4, so 57 minus 4 is 53. So this way, going from here to here is good. If we reversed it, did anything change? Not really. If 3x minus 4 equals 53, what did we just find out x was? It was what? 19. So this, whether it's going this way or in the reverse, this is the only one that's going to be true, whether it's the conditional this way, or if we were to find the converse, it'd be true. So the only answer is C. This will be on your test. So if you need help with this, you come to tutoring, right? Okay. Which of the following statements is a biconditional? Okay, so a triangle is a three-sided polygon. Yeah, because in order for me to write a biconditional, what do I need? I need first, well, that's too big. I need first the conditional and the converse. So what is the conditional of this statement? If I have a triangle, then it is a three-sided polygon. Okay, now what is the converse? If I have a three-sided polygon, then it is a triangle. Both of those statements are true, so I can just combine this into an if and only if. So a figure is a triangle if and only if it is a three-sided polygon. So we need to look for that. This is wrong because this says not. This has an if and a then. This has an if and a then, so the only one is D, because this is the only one that says if and only if. Okay, so we're almost done. Okay, let statements P, Q, and R be as follows. Substitute. Okay, it looks really hard, but it's really not. They're giving you all these options, but they only want you to do P, if P, then R. So where's P? So they want me to write if angle A and angle B are a linear pair, then where's R? Angle B, angle A and angle B are adjacent angles. So just put an if here and then here. This question confuses students because they see all this and they think it's a big deal, but they really just want you to write this. If P, then R. So if this, then that. And that is answer D. Okay. Let statements P and S be as follows. P is this, S is that. Substitute for P and S and write the statement so that it reads P if and only if S. Remember, this double-sided arrow reads if and only if. So that means this is P if only if S. So angle A and angle B are a linear pair if and only if angle A and B are adjacent and supplementary. We actually did learn about that. What does it mean to be a linear pair? It needs to be adjacent and supplementary. So the answer here is A. Okay, look at the if and only if. Alright, so that's pretty much it. Your quiz will be easy, I promise, but just make sure that you study and start coming to tutoring if you need it.